The time has come to get the ship out of the water.
My name is Gijs and this is my dad. And this is Schoener Tijgerhaai. We have recently started a major rebuild to get her ready for new adventures. And we're sharing the process with you. Subscribe to stay tuned.
Drydocking is something that we only do every 5 to 7 years. So this will be the only time during the rebuild that you can do any work on the underwater part of the hull. Meaning that apart from the obligatory hull thickness survey, we have to make the maximum use of this opportunity. The ship is going into an indoor dry dock, meaning that we are not dependent on the weather to do welding and painting on the outside of the ship. There's only one thing standing in the way for that. Two actually, the masts. Thankfully the dry dock is prepared for that. There's a slot in the roof to be able to fit sailing ships. The slot is 1.5 meters wide, so we have to fold down the cross trees in order to fit. It looks a bit off, but without the sails there's not much force on the masts, so we can do without the cross trees for a short trip on engine to the dry dock. All other preparations were done in the past months, so we can fire up the engine, install the navigational equipment, and then, for the first time in 5 years, the ship is on its way. During this 4-hour trip through the freezing canals, let me tell you what's on our dock list, apart from the hull thickness survey. The main thing is installing a bow thruster, but we're also going to do an anchor chain inspection, water tanks inspection, cooling water renewal, work on the underwater overboard valves, replacing broken echo sounders, new layers of paint all around, and if there's some time left, increase the area of the rudder a bit. Meanwhile, in the dry dock, the dock blocks are placed. So after the dock is filled up, the door can be opened. After carefully parking the ship with the masts in the roof slot, all pumps are fired up to quickly empty the dock again. In the meantime, we are emptying the potable water tanks, which have to be inspected and cleaned because they haven't been opened in 20 years. Before we do anything else, the hull has to be pressure washed, which is a fun job that we gladly leave to the dock workers. Dry dock is always a hectic period where a lot of work has to be crammed in a very limited time. To make that possible, there are a couple of skilled metal workers running around to help. As soon as the ship has dried, we can get the formalities out of the way. The hull thickness surveyor taps with the hammer on the side of the ship and listens to the sound it makes. Based on the sounds, he determines where we have to grind off the paint to do an electronic measurement to determine the actual thickness. The same surveyor also did a safety inspection of the entire ship and had no remarks, so all our preparations from previous videos have paid off. In the meantime, we can run out the anchor chains completely so we can inspect them and renew the markings. The bad news is that there's 2 holes in the boat and 2 parts of the hull that are quite thin. The good news is that we have 2 weeks to fix that. The 2 holes are exactly on opposite sides all the way in the bow, underneath the anchor chain locker. This is a notorious place for rust on the inside of the ship because there's always water dripping off the anchor chain, and it's a place that's near impossible to reach for maintenance. Now of course the question arises, if there's 2 holes in the ship, why did it not sink? Well, Dad knew about this notorious place, so a couple years back he had an extra horizontal steel plate welded in place, creating a flat floor underneath the chain locker that's easier to maintain. And in fact a watertight double bottom in the most forward part of the bow. The only downside to that is that we cannot reach the rusty hole from the inside. That's not really a problem, we just have to make the hole big enough to be able to work on it from the outside. Starting by removing the concrete that's holding the steel ballast in place. The 2 other bad parts of the hull are exactly where the hull is at its widest, on both port side and starboard side. There's no rust there, but we suspect that the hull plating is just worn by years of sailing around. Especially from when the ship was used as a salvage tugboat in the 60s. They weren't very gentle with it back then, and the widest parts are where the ship would always bump against the quayside. Anyway, on some places the plates are less than 4 mm thick, which is half of their original thickness. We are going to replace those parts for new 8 mm thick plates. This means cutting some giant holes in the side of the ship. In the meantime, since we're turning the ship into a Swiss cheese anyways, the guys straight away want to start with the installation of the bow thruster tube. So we'll make some space for that in the forecastle. These guys work so much faster than we do, using plasma cutter and CO2 welding. We cannot compete with our cutting torch and stick welder. But that's a good thing, since we're on a tight schedule. Anyway, they work so fast, I'm having a hard time keeping up with filming everything, since we're also running around doing all the other stuff that needs to be done. Like removing the toilet, because we want to replace the overboard valve for the 3-way valve to be able to choose between straight overboard or to a sewage tank or sewage treatment unit. The flange nuts of the valve are very stuck, so our torch is not yet completely obsolete. We have also removed the suction valves from the sea chest in the engine room, which are currently not in use, but they might be in the future for things like a freshwater generator. All these bronze valves have to be taken apart, made easygoing again, greased and get a fresh coat of paint. We do get to take part in the Swiss cheese party as well, because we are installing new depth sensors. These sensors use echo sound to measure the distance to the bottom. So they have to be installed in the bottom of the ship through the hull. There are 3 old ones installed, but they are all broken. Unfortunately, only one of them has the same dimensions as the new ones. So we have to close up 2 holes and create one new one. We are making some more holes for the overboard valves of the forward toilets and the sewage tank or sewage treatment unit. Let's have a look how the guys are doing. The holes for the bow thruster pipe are cut and the pipe is getting prepared to be welded in place. The standard procedure for this is to let it stick out on both sides, weld it completely in place and then cut off the surplus material. This cutting off is done by the plasma cutter, which is very fast and very neat. In the meantime, the hole in the bow is already being closed. A bow thruster pipe in the bow of a ship can cause the flow around the hull to be disturbed, as it catches some of the incoming water, which crashes into the backside of the pipe. That can cause the ship to react strangely while trying to sail in a straight line. To reduce this effect, a little ramp is installed in front of the pipe to direct the water around it. To prevent stuff from getting caught in the bow thruster propeller, we're installing protective steel strips. Now that that's all finished, the new steel parts get a layer of epoxy primer. Off to the side of the ship, there's a gigantic hole and a new 8mm plate is being prepared to fit in said hole. And on the other side, same story. During the weekend, when there's no steel work going on, we have some time to renew the engine coolant and drain the fresh water tanks. It's best to do these jobs in dry dock because there are drain plugs in the hull on the lowest points of both water tanks and the bilge keel coolers. All our engines use normal blue engine coolant, which should be exchanged around every 5 to 7 years, because it will lose its anti-corrosion and anti-freeze properties over time. During the previous dry docking there was no time though, so this coolant has been in there for more than 10 years. A good indication that the coolant has lost its properties is that it's not blue anymore, but just colorless. What's worse is that the last coolant coming out is starting to turn black, indicating that there's some corrosion in the system already. Conclusion: the cooling water change was very much overdue. Let's get some beautiful blue fresh coolant inside. Draining the water tanks works similar. We've already pumped out most of the water during the docking process, but the last bit is hard to pump out due to the fact that the tank bottom is not flat. For that purpose there's a plug in the hull. These tanks are coated with Portland cement, which works great to prevent rust and has no toxic chemicals. We have to clean and inspect the tanks to see if no cement has come off the walls. You can see that through the years a lot of minerals from the potable water have settled on the bottom and sides of the tank. So we will rinse that out with clean water. I found one part of the tank where the cement has come loose. So we'll have to slap on some new cement to prevent rust. After drying, the tanks can be filled again with fresh water. The dock staff had some time left, so we asked them to increase the size of the rudder by adding 15 centimeters or half a foot on top and 15 centimeters on the bottom. In our experience, the rudder works great while on engine, but during sailing it can do with a bit more area. The bottom part of the rudder has the most clean flow of water towards it, but it's also the most vulnerable for running aground. On the other hand, there's a lot of space above the rudder to install an extension. That's why we have chosen to add a bit on both sides. Since the bow thruster pipe is completely finished, we can install the motor and bolt it in place. In the meantime, all the steelwork is finished, so the ship is ready for a layer of aluminum based primer. The new pieces in the sides are just finished, so they first get their layer of epoxy primer and the aluminum based primer afterwards. With the primer on, we can install the new echo sounders. They are sealed watertight through the hull, but they're still just plastic plugs. So to be prepared for leaks, they're installed in closed off pots, with the wire running through a pipe that has its opening higher than the water level. If water ever leaks in, it will stay in the pipe and not sink the ship. It's also time to reinstall all the overboard valves. After which the hull gets its final layer of anti-fouling. Before we get her into the water again, the anchor chains are marked and can be hoisted back in. With everything freshly painted, the day has come to swim again. During filling up, all valves, flanges and welds are checked for leaks. Only one leaky flange was found, and that was a matter of tightening the bolts a bit more. And there she is, looking sharp, back in the water. There is some paintwork remaining inside, but we didn't get to that yet. After that, this chapter of the rebuild is finished. The guys from Shipdock Drydocking did a fantastic job, and we were able to finish everything on our dock list within the 2 weeks, which is a rare thing, because usually the dock list only seems to grow when the ship is on the dry. Next time we'll continue with the rigging of the forestays and work on the interior. But this is all for now. If you have any questions or remarks, be sure to ask them in the comments. Thank you for watching, and I'll see you next time.